Okay, this is the last lesson for this unit, solving systems of linear equations, of equations algebraically. So this is all going to be sort of an algebra-based lesson. What's happening here is we want to solve the system. Now, when we solve it, what it actually means is that we're finding the points of intersection between this linear system and this quadratic system. So to help you understand this, let's label this as 1, and we'll label this as 2. Okay, so we have those two systems, and we're going to try and figure out how we're going to find out where those two are crossing over each other. All right, so what we're going to do is we're going to substitute 1 into 2, because you notice that 1 is already solved for y, so y and 1/3 x squared minus 3 is the same thing. So this y here, we're just going to substitute in 1/3 x squared minus 3. So this is going to be x plus 1/3 x squared minus 3 equals -3. So we'll add 3 to both sides, and that'll come out to be 0 on the right-hand side. To make it easier to factor, let's multiply these two by 3. So it comes out to be x squared plus 3x equals 0. We'll take out greatest common factor of x. X times x plus 3 equals 0. So that means that the x-coordinates of the solution are going to be equal to 0, and it's going to be equal to -3. Okay. Once we have those x-coordinates, we're going to substitute it back into the equation to find out what the y-coordinates are. So I go back to any one of the two equations. So let's use equation 1. 1/3 0 squared minus 3. So my y is equal to -3. Okay, sorry, I want to say that this is when I substitute 0 in for x. In this one, let's put in -3, so x equals to -3. So it's y times 1/3 times -3 squared minus 3. So -3 squared gives you positive 9 divided by 3 is 3. 3 minus 3 means that the y is going to be equal to 0. So we can say that the solutions are 0, -3, and -3, 0. Now there's 3 possibilities here. When we're talking about a linear quadratic system, there's 3 possibilities for answers. One is in which the quadratic and the line never meet. So there's no intersection. Oops. Let's say there's no solution for that. Okay. And just the x and the y variables will disappear and you won't be able to solve for it. There's another situation where don't like that, I missed it. There we go. It touches the line will touch the parabola in just one point, so this will be one solution. So that'll be like x equals a number if you're solving for it. And then the third one, which is this kind of situation here, where there's 2 solutions, one here and one there. So there's 2 solutions. So those are the 3 possibilities. Okay, so let's go for 166 and try that. Okay, just a reminder, I've said this so many times, you guys are probably tired of me saying this to you, but all the full solutions for the examples are in your work text. Alright, so this is now a quadratic problem. Y is equal to x plus 2 squared minus 1, x squared minus 4x minus 5. So these are 2 quadratics. Now there's 4 possibilities happening here. Okay, so first possibility, they don't hit, so there's no solution. You'll know that because the variables will disappear and you won't be able to solve for it. Here, the 2 vertices of the parabolas are just barely touching, so that's going to be one solution. Here's a common one where the parabolas parabolas are intersecting in two spots, here and here. So there's two solutions. And then the last one, it's a little bit hard to draw the formulae for both parabolas are identical to each other, and one is lying right on top of the other. And so this is infinite solutions. Okay, so we'll call this one 1, call this 2. Notice that y equals that and y equals the second. We know that y is going to be equal to y, so we'll just set them equal to each other. X plus 2 squared minus 1 is going to be equal to x squared minus 4x minus 5. Okay. We're going to FOIL this out. X plus 2 squared is equal to x plus 2 times x plus 2. So that's going to give us x squared plus 4x plus 4 minus 1 gives us plus 3. So that's x squared plus 4x plus 3 is going to be equal to x squared minus 4x minus 5. We'll subtract x squared from both sides, so that's going to eliminate that. This is going to be 4x plus 4x is going to give us 8x. We'll subtract 3 from both sides. It's going to be equal to negative 8. X equals negative 1. Now there's a 1 solution, which means that we're looking at this kind of a situation here. Now we'll sub x equals negative 1 into 1. You could do 1 or 2, it doesn't really matter. So y is going to be equal to negative 1 plus 2 squared minus 1. So y is going to be equal to 0. So we can say here that solution is negative 1, 0. Okay, go to 168 and try the sample there. Okay, last one. Moving on to the word problems. So a couple of phases here. You want to make sure that you define your terms and then also take a look at setting them up. So this one says two numbers are related in this way. The square of the first number subtract the second number is equal to 5. Okay, so the square of the first number. So let's just make the first number being equal to x. So the square of the first number subtract the second number is equal to 5. So we'll call that 1 as a quadratic. The first number is equal to the second number, subtract 7. The first number, which is x, is equal to the second number, which is y, subtract 7. That's linear. So we have a linear quadratic system here. Create a system to represent this relations. Let's solve them both for y. So we're going to have y is going to be equal to x squared minus 5. That'll be our 1. And y is equal to x plus 7. That'll be our 2. Okay. Well, we know that y equals y, so let's just set these two things equal to each other. X squared minus 5 is equal to x plus 7. We'll gather them all into one side. Think of the factors of 12. That could give you a 1. 4 and 3 look okay. Because this is negative, the higher of the two numbers must be negative. And because the 12 is negative, the other one must be positive. So my x-coordinates for the point of intersection are going to be 4 and negative 3. Okay, so let's substitute them in. Let's do x equals 4, and we can put it into 2 because it's a nice simple equation. Y is equal to 4 plus 7. Y equals 11. What if we had x equals 3? Sorry, negative 3. So y is going to be equal to negative 3 plus 7. So y is going to be equal to 4. So here my solutions are 4, 11, negative 3, 4. Okay, try the sample on 170.